Hey there, Python trainer Ruben Lerner here. And this time I have a question not only from my free weekly Better Developers list, but also one that is asked of me at a lot of my corporate training gigs. And the question, in its most sort of precise, specific form, goes like this. Let's say I have my list equals 10, 20, 30. And then I have def my func. I'm going to say x here. I'm going to say x equals 100, 200, 300. So we have my list being a list 10, 20, 30. Inside the function, we're going to assign x to be 100, 200, 300. So now if I call my func on my list, what is the value of my list? And the answer is 10, 20, 30. Now, there's a second part of this question as well, but I first want you to understand what's going on here and why it's working the way it does. So what do we have? Like, what are the different parts that are working here? Well, we have the variable mylist, and it refers to 10, 20, 30. And that's a global variable mylist. We have the local variable x, and it also refers to 10, 20, 30 at the start. So basically, when I call my func on my list, so my func is a function, we call it with my list, meaning that the local x and the global my list are both referring to the same list. So far, so good. Then we get to line 4 of the function. And line 4 of the function assigns x to be the new list 100, 200, 300. What does that mean? It does not mean that we are replacing the location in memory that used to have 10, 20, 30 with the new list 100, 200, 300. Doesn't mean that at all. Rather, it means that we are saying that the name x, the variable x, the identifier x, now refers to 100, 200, 300. So before we had global refers to 10, 20, 30, and local variable x also refers to 10, 20, 30. But now local variable x will only refer to 100, 200, 300. And that's always the case with assignment in Python. Whenever I say that, my var equals my val, if I do that, then all it means is that the value on the right is now referred to by the variable on the left. That's all it means. Does it mean that the value no longer exists? Not necessarily. If someone else is referring to it, then that's fine. And indeed, that's what's going on here. Where after I assign x to be 100, 200, 300, so fine, x is pointed to 100, 200, 300, but my list, the global variable, continues to refer to 10, 20, 30. And so when the function returns, the local variable x goes to its, goes to meet its maker, as it were. It's destroyed because local variables are always destroyed at the end of a function call. And then actually, because there are no other references to this list, 100, 200, 300, it is then released from memory. But then if I print my list, it's still 10, 20, 30. So we see in this example here that my list was never touched, was never changed, was never anything. And my list, the variable referring to that list, 10, 20, 30, no one ever touched it either. In fact, there is no such thing as really a pointer in Python where I can, via one variable, affect what another variable is assigned to. But now let's look at the second part of the question, because this is where people get really confused, especially after they've seen this. So if I say my list equals 10, 20, 30, and then I say def my func x, and then I say here x of 1 equals, and let's make this exclamation points. Now, what's going on? Well, first of all, let's see what happens when we run it. So we're going to hear 10 exclamation points 30. How is this possible when we just saw and said that changing one variable won't change another? But we're not assigning to a variable here. We are assigning to an element of the list to which x is referring. There's a big difference between saying x equals exclamation points and x of 1 equals exclamation points. In the former, we're saying that the variable, the entire variable, is going to refer to something new. And when we do assignment in Python, we break any connection that the variable had with any previous values. But that's not what we're doing here. Instead, what we're saying is x of 1 equals exclamation point, meaning that x, yeah, we go to it, we pull out its 1 value and replace that value, only the value at index 1, with exclamation points. When we do that, when we assign to x, to one element of x, we are assigning to the same list as my list points to, because remember that my list refers to 10, 20, 30, and x also refers to 10, 20, 30. Indeed, x and my list refer to exactly the same list. So modifying X means that we're modifying my list. And that's exactly what happens here. So this is not a matter that should be too confusing, although it is. It's a big difference, though, between assigning to a variable and assigning to an element within a mutable collection. Now, if we have any other sort of immutable type, then it'll work like this first one. So for example, if I say here, let's say x equals, let's do this, def myfunc x. And we're going to say here x equals 1, 2, 3. And if I say here a equals 99999, and then I call myfunc on a, print a is not changed. Why? Because here we assign to x. But there's no way, right? So x is going to be 1, 2, 3, at least within the function, but a is never going to change. It's always going to be 99999. Now, the fact that a is an integer and thus immutable means that there's no way for us to change any part of it, right? It's all or nothing, right? That's sort of the nature of an immutable data structure. So it's really the fact that lists are immutable that even gives us this sort of weird, confusing kind of behavior. Okay, I hope that this helps to explain it at least a little bit. If you have questions, comments, thoughts, please don't hesitate to reach out to me. I'm on Twitter. I'm available via email. And remember, if you want to get free weekly articles about Python and improving your work as a software developer, just subscribe to Better Developers. I will be back in another video very soon.